Welcome to another class in system programming. So now we are going to discuss a small program. So we just started with the system programming. We saw little concepts of system programming. Only when we explore a program, you will actually understand whatever concepts we have theoretically studied. You will only then be able to understand. Right. So the first program which we are going to write, okay, without knowing the instructions, because we are not going to actually study it as a practical paper. So we will not be covering the instructions. We will just directly go to the program and just instructions which are there, which are uh, for this program, so which are meant to be for this program. Only those instructions we are going to discuss, right? You are going to understand. So we are not going to be really bothered about all the instruction set. We are only going to see a few instructions just so that we'll be able to write this program. That's it, right? So we are not, it's not a programming paper anyways, right? The first program, so this is going to be the only program we are going to discuss in the whole of this unit. This is the program. The program is supposed to add 49 to 10 different numbers. Okay, I repeat it. A number 49 has to be added to 10 storage locations. So there will be 10 storage locations which will have data, and you are supposed to add 49 to those 10 data. So or else let me break it down and tell you like this. Let us say there is an array which has 10 values consecutive, right? So let us assume it is an array. It's actually, we don't have array concepts here. So just that there are 10 memory locations. So there is, let us say, there is an array, say of 1 to a of 10 is, let us say, is the array. So what I'm supposed to do, already there will be a value stored in that particular a of 1, right? Let us assume there is already a value stored. So my program should add 49 to the existing value, right? So my program, what it should do, it should add number 49 to that particular value which is already present, right? Similarly, I will add 49 to a of 1, 49 to a of 2, 49 to a of 3, and so on. So till a of 10 I have to add 49 to every number present there, right? So I am repeating, there is no array concept here. I'm just giving that example so that you can visualize whatever I am telling you. Right. What are the assumptions to write the program? So we have seen instructions, right? You remember instructions we have seen. So RS, RX and all. So we will be using RX instruction. So for that you should know some things. There should be some assumptions which you should be understanding about this particular program. First assumption is that the program is starting at a relative address 0, right? Yes. So the program, this is the program. So you can see here. So this is going to be your absolute address. Wait a minute. So there are two addresses. You know, there is a relative address and there is an absolute address. This relative address is the address we are writing the program. This is going to be your absolute address. So what is absolute address? Whenever you are loading into the main memory, whatever location you have been given, that's where you will load the program. That is called your absolute address. Yes. So this is going to be your relative address. Always we assume that every program starts with a relative location 0 is what is the assumption. Yes, so these are the lines of coding. We will see what are the assumptions. The first assumption is our relative address. So every program is going to start at location 0, relative location 0. And we are saying that 48 is the absolute address. Starting absolute address here is going to be 48. Okay, so here you can see that. So what I'm saying, let us assume that this is your main memory and this is the place given for your program to be stored. This starting address where we are going to store our program, that is nothing but it is 40, it is given as 48. You understand? This is the meaning of it, right? The next assumption, let us see. The program is starting at relative address 0. Yes, we saw that. Absolute location is 48. We saw that. Whenever the absolute address is given to you, immediately the next thing you should remember, think of, is your base register. Okay, whichever is the starting address for your memory location, whichever is your starting absolute location, will be the base register value. See here 48 is where your program is going to begin. So I'm going to say 48 is the location where my program is going to begin. So what happens, 48 now becomes your base register value, right? So 48 becomes your base register value. So what happens now, 0, line number 0 will be stored at location 48, right? Next instruction will be stored at another memory location, next instruction is going to be stored at another memory location, and so on. It's going to go on like that. So we will see that clearly in the next slide. We will actually be discussing all of that. Now just remember the first line of coding, relative address is 0, absolute address is 48, which means your base register value is going to be what, 48. 8. So your base register value, whatever base register we are using, the base register value should be 48, right? That's what we are actually discussing, right? The next assumption is the 10 numbers begin at location 904. Okay, what is this? Why is this assumption? I will tell you. See, we are writing the program from 0, right? It goes on. We don't know how many lines it is going to take for us to write the program. So we are leaving sufficient space and going to what? Relative address location 900, and we are going to store this number 49. So why we need to store 49? Because we have to add 49 with all the data we have. Yes or no? So that 49 I am first storing in the location 900. 900 I am storing the number 49. Let us we talk about relative address only. Then we will see how to calculate the absolute address. Right? So now I don't want to confuse about relative and absolute. Let us now talk about only relative address. At 0 we started the program. At 900 we are assuming that at 900 I am storing the first value, which is 49, right? 49 I'm storing at location 900. Okay, here every data here, okay, every data or every number here is called it's going to occupy one full word. We will say that it is one full word. You just have to remember every data here is going to be of 4 bytes. That much you remember enough. So it's going to be of 4 bytes. So if we start storing 49 at 900, so at 900, 901, 902, 903. See, all these 4 bytes will be used for storing this number. 904 will be where you can store the next data. Next number you can store at location 904. The next one at 908 and so on. So every number here is going to occupy 4 bytes. Yes. Now 49 is stored at 900. At 904 we are going to store the first data. So what I told you to remember it as a of 1. So let us say this a of 1 is going to be stored at location 904. I will just simply write it as a1 because writing is little difficult here with mouse. Right. So data 1 is nothing but your first data, first number. What am I supposed to do? I am supposed to add 49 to the first data, then I will add 49 to second data and so on, right? So first data's location is again 904 and so on 908. So you should be storing how many numbers? 10 numbers. So here it is given 940 is where you store the last number. 940 is where you are going to store the last number, right? So these are, you have to always start with some assumptions. You have to assume something, only then we can proceed with the program. Next assumption here, the number 49 is stored at location 900. Yes, the 10 numbers are going to be stored at location 904. These are the two things we saw. The 10 numbers, first A1 is going to be stored at 904. Okay, A2 at 908. Okay, A3 at 912 and so on. Till 940 we are going to store 10 numbers, right? At 900 what are we storing? This 49 we are storing, so that we wanted to add it with all these numbers, right? So next, what is the assumption? We have 16 registers in IBM 360. There are 16 registers I have told you. So it is going to start from register 0 to register 15. Register 0 to register 15. Okay. Here in this particular program, I am going to use register 1 as the base register. Right. So there is a way to say that we will see later, much later. How do I assign register 1 as the base register? All that we will see later. Now just assume base register is nothing but register 1. Register 1 is my base register. What is the meaning of it? So the value 48 will be stored where? In register 1. The value 48 will be stored in register 1 because register 1 is now the base register. Yes. Next, register 0 is your index register. So index register we are not going to use in this program. So only in case of accessing consecutive locations we will be using index register. To start with, we are not going to use index register. Maybe later we will try using the index register. As of now, register 0, okay, is your index register. As of now in this program, register 0 is the index register, and the value which is present inside register 0 is also 0. So don't confuse yourself. 0 here doesn't mean the value. It here means 0 in your program. If it written in your program, in your instruction, it means register 0. Inside register 0, the value 0. We are assuming it is also contents of register 0 is also 0. That is the assumption. Right. As I already told you, all the values data present here, everything is one full word. It's nothing but 4 bytes. Right. So one more thing you can say, since I said register 0, register 1, next register 2. So it is used as an accumulator here. Mostly it is used as an, usually register 2 is used as an accumulator. Okay. So these are the registers we will be now handling. 0, register 0, register 1 and register 2. Let us go to the program. Okay, the problem is I have to add 49 with 10 different numbers. Yes, we will leave that. We will come back to the coding part of it. So we have spoken about relative address. We have spoken about absolute address. We have told where data is stored. Okay, data is stored at location starting from 900 it is stored. So every data value is going to take 4 bytes. So is your instructions. Here, this every line is one line of instruction, right? Even instructions are going to be stored in 4 bytes. Why? Because all these three instructions which we are going to see are all RX type of instruction. RX type of instructions will require 4 bytes. So no confusion at all. Whether it is instruction, 4 bytes. Whether it is data, 4 bytes only. Just remember 4 bytes for everything. If it is value also, we are going to use 4 bytes. If it is going to be an instruction also, we are going to use 4 bytes only. You don't have to be confused. Right. So you can have this doubt, or you may not feel little insecure because you're starting with programming. I don't even know any instructions about IBM 360. Don't worry. These are the only 3 lines of coding you should know. Okay, only these 3 lines of coding you should know and understand. It is very, very similar to 8085. You will definitely understand it. Don't worry about any other line of coding. Here and there, theoretically, we will study some commands, but in the program we are only going to use these 3 commands. So just these 3 commands you can do it. Yes, right. So just 3 commands. So what is these commands used for? First command, you tell me, guess what is this? L is a load instruction. A is a add instruction. ST is a storage instruction. Yes, load, add, store. Load, add, store. Just 3. Yes, first let me break down and explain what is this instruction, then I will say how what the program means, right? So L instruction, first of all, this L instruction, L is nothing but loading. Okay, so L is going to be load. So load instruction, so what it has, what is the syntax you see? L, okay, there should be a space there because that is an instruction, like load, like STA, LDA, STA and all, no, you studied. Similarly, L is the instruction, space 2 is the register. 2 here means register 2. Okay, 2 here means register 2, comma 904 of 0 comma 1. So what do you mean by 904 of 0 comma 1? 0 is your index register, 1 is your what register? Base register. You understand? The syntax is going to be like this. L 2 comma 904 of 0 comma 1. Okay, what is each thing? This is your register 2. Yes, this is your nothing but your displacement. Yes or no? This is your displacement. We saw in the instruction types, this is nothing but your displacement. Right. So this is your displacement, and this is your index register, and this is your base register. You understand? The format is L 2 comma 904 of 0 comma 1. Okay. What are these two? So this I told you is the opcode. Okay, it's going to be an opcode. These two are operands. 2 is one operand. This address is another operand. Address format is 904 of 0 comma 1. Completely it is one address. The whole thing here, it is nothing but one address. The whole thing here is going to be one address. So what is that we are doing here? We are going to have an opcode and 2 operands. L is your opcode. 2 is an operand. 904 of 0 comma 1 is the operand. Yes. This 904 of 0 comma 1 represents an address. Okay, let us say 904, what is there? 904 data 1 is there. Okay, so some value is there. So what are we going to do? Load the contents of 904 to register 2. Load the contents of 904 to register 2. That's it, simple. Yes. Why then? Why do we have to use 0 and 1 here? Because this 904 is, we are talking in terms of relative address. If I wanted to find out the absolute address here, which is 952, I have to add the index register value and the base register value. Okay. So we will leave that part now. Let us try to understand only from the location 904. Okay, load the value present at 904 into the register 2. Load. Okay, load the value present in 904 to register 2. Okay, that is the load instruction. Right, you understand? Load 2 comma 904 is like microprocessor right to left. So loading from the address location and putting it inside your register 2. That's what we did. Yes. So now we will see what the 0 and 1 does here. 0 I told you is your index register and the value also is 0. Right. 1 is nothing but your base register whose value is 48. Yes, index register, base register. Now, there is a mantra which you should remember, right? That is the formula to calculate your absolute address. Absolute address is this. Right? This address is called as your absolute address. How do I calculate my absolute address? Absolute address is equal to relative address, yes, plus contents of index register plus contents of base register. Simply I will tell you relative address plus index register plus base register. Absolute address is equal to relative address plus index register plus base register. What is relative address here? 904 is the relative address. What is the value of index register? 0. What is the value of base register? 48. So your absolute address is equal to 904 plus 0 plus 48. What are you getting? 904 plus 0 plus 48, right? Or you can say 904 plus 48, where index register is assumed to be 0. So I will directly add my what base register value and then say find out the absolute address. Yes, so 904 is your relative address. Add 48 to it. What do you get? You got the absolute address 952. That's it. That's why you have the address in such format. You have the address in such a format. Why? Because this is the idea. Okay, so we are going to use the whole thing to find out the absolute address. So because anyway once you load the program into the main memory, it should not go and search for 904 because 904 address may not contain this particular data. So we have to say it is not 904, relatively the relative address, which is the displacement plus index register plus base register, is what you have to actually load the value from, is what information you are giving to the what your operating system or your processor, whatever you say, right? Here load, we have loaded one value from 904 into register 2. Done, right? Next one, what is A means add instruction. I said A is add. A, the syntax is going to be like this: A space 2 comma 900 of 0 comma 1. So now on I'm not going to explain you 0 comma 1. You should know 0 comma 1 is index register, base register, all this story you should know, right? Let us now only I'm going to talk about the relative values only. I will be now talking about, right? A space 2 comma 900. So what do you mean by A space 2 comma 900? What do you mean by that? Yes, so you're saying there is a register 2 and there is a address location 900. So there is a register 2 and there is a address location 900. So what do you have to do? Add the value present in 900 with the contents of register 2 and store the resultant register 2 itself. Yes, whatever is the contents of location 900, add it with the contents of register 2 and store the resultant register 2 itself. What is there in 900? 900 has 49, right? So 900 has 49. So I have to add 49 with the contents of register 2. That is the line. That line says you have to 49 has to be added with whatever is the contents of register 2 and register has to be stored in register 2. That is the meaning of this particular add instruction. Yes, load instruction is done, add instruction is done. Store instruction. Okay, store instruction, what it does, it has the syntax is like this: st space 2 comma 904. Okay, like in microprocessor, it only goes from here to here. Store instruction, right? Everything went from right to left. This is going to go from left to right. Okay, the contents of register 2 has to be stored in memory location 904, right? Has to be stored in memory location 904. That is the store instruction. Just three instructions you have to remember: load, add, store. Yes, we will again go see the same instructions and try to understand what is the program, how it is written, right? Load 2 comma 904, right? Load the value present in location 904. 904, what value is there? It has the data 1. Let me assume the data 1, what is the value present there? Let us say a of 1 or something. I'm going to say it is going to be 10. I'm going to have 10 stored in that particular location. So what I should do? I'm just saying 10 is an example, or I can even say data 1. So if I say 10, maybe you can be able to relate a little bit, right? So what I should do? I'm loading the value present in 904 to register 2. So what happens now? My register 2, okay, so 2 is nothing but your register 2. My register 2's contents is equal to what? The data 1 is equal to data 1, right? So register 2 is equal to data 1 after I have loaded from 904. So 904's value is going to be loaded into register 2. So register 2 is equal to your data 1. In our case, let us say assume that it is 10. Right. Next, add the contents of 900. What is the contents of 900? 900 is here. The contents of 900 is 49. Add 49 with register 2. What is register 2? Register 2 is data 1. With that I have to add what? Number 49. Okay, so what I have done, I have written add instruction 90 no, I'm sorry 900 contains 49. Add the contents of location 900 which is 49 with register 2. So register 2 already has data 1. I want to add these two. Yes, so I will get a sum here. If I assume that data 1 is nothing but 10, then 10 plus 49 is equal to 59. So where is 59 now stored? It is stored in register 2. So what is the work of add instruction? Load the contents of location 900, add it with register 2 and store the result in register 2 only. So which is the result now? That 59 is your result. That is stored against, we have stored it back in register 2. So register 2 contains 59, the sum. Yes. Store. Now the value, my sum is in register 2. I have to store it in location 904. Why 904? That is where data 1 was. Okay, data 1 was in 904. I added 49 and again I have to store that sum again where? In 904 only. Similarly, I will add 49 with the data 2, store the sum in 908. I 49 with the data 912 and the sum has to be present in 912 only and so on. That's what we are going to do. So what have we done here? Whatever was the sum in register 2, I'm going to store it back in 904. Okay, so let me again tell you, from 904 we took one number, stored it in R2, right, register 2. So from 900 we have taken another number which is 49. We have added that number with register 2. Then the sum is now present in register 2. What are you supposed to do? Store it back in 904. Store it back in 904. It's done. These three lines you remember. With this we are going to actually see three different topics, right? So this much you have to remember, this much coding has to be remembered. Yes, so what all you have, what is the contents here in this particular slide? So you have the base register value which is 48. Okay, so base register value was there which was 48. So that is one thing you had. This is the coding. So I'm going to start with 0. So this will be my relative address of this code will be 0. What is the relative address of this one? Can anybody tell me? Yes, 4, because everything is 4 bytes. So it's going to start from 0 1 2 3 will be occupied by first instruction, 4 5 6 7 will be occupied by second instruction, 8 9 10 11 8 9 10 11 will be occupied by this store instruction. You understand? So these are the relative addresses. With this, can I calculate absolute address? Yes, I can calculate. What I should do? I should add the base register value and the index register value. Index register is 0, so we will leave index register. Just add 48 with all these 4. So what will be your absolute address here? 0 plus 48, 48 will be the absolute address. So which here, what will be the absolute address? 48 plus 4 will be what? 52. Yes, this is going to be 52. So 52 will be the absolute address for this particular line. Yes. Yeah. This is 8 is the relative address. So add 48 with this. 48 plus 8. Okay. It will be 56. So that is going to be the absolute address. So once you write the program and write the relative address, absolute address you can write on your own. You don't have to worry. Just have to remember 48. That's it. So don't please try to mug up these programs. Mugging up is very difficult. Okay. It is going to be time consuming. Just remember understand these three instructions, remember the format and the instructions enough. You can cover the next three topics with this. You understand? Yes. So what we did today, we have seen a program, right? We said these are the assumptions and then we said this is the three instructions and we tried to understand all these three instructions. What are we supposed to do? So what are we actually supposed to do is now add number 49 to 10 memory locations. What have we done? We have only added the number in with one memory location. We have added 49 with the first memory location. That's all we did. So we are just saying I have understood the programming. Same thing I will do for all the other data. So I have to add 49 with all the data, 10 data here. That is also there pending. Okay, so since I have written the coding, I have understood and written the coding for the first one. It is easy to implement it. Yes or no? So that's what we are going to do next. Yes, so this is the first method. Okay, so the same program we are going to write it in a method using a method called long way no looping. Okay, long way, no looping. It is very literal, right? You can understand. There is no loop command here. We don't have a kind of while loop kind of a thing. It's a long way, which means, so whatever I did, what I did was I only wrote 3 lines of code and I said this 3 lines of code will be used to add 49 with the first number. I will be using these 3 lines of code and add 49 with the first number, right? How will I, what will I do for the other things? If that's a question, the solution given here is I will repeat the same thing 10 times. Yes, so which means it's a long way, no looping. There is no looping, it is a long way. That is the first method we are going to do. So why this is the method we are going to do is that's how we write coding, right? That's why how we write programs. So every time we try a new technique and then you are going to make it more efficient. That is the same thing we are going to do here also. First thing we will write the first understand and we have solved the problem. The solution is here. Will it work? Yes, it will definitely work, but it is a long way. Okay, but fine, it will work, still it will work. So let us see the program. It is the same program whatever I told you. These 3 lines we have already seen, so you should not have any doubts in these 3 lines we have seen. Sorry, not used to it still. Okay, so right, so these 3 lines of coding you should not have any problem. You understand, these 3 lines are going to be the same, right? What is the method? Long way, no looping. So what I will do, it's your technique only, copy paste it again and again. How many times you have to copy paste? 10 times. Okay, I told you the coding is same. Is it same? If I say same line I'm going to copy paste, what will happen? I'll add 49 again and again with data 1 only. I'll keep adding. That should not be the case. First I should add 49 with data 1, second I should add 49 with data 2, and so on. So how can I do that? So first 3 lines of coding, I'm going to load a number from 904. Okay, load a number from 904, that is where my data 1 is present. Okay, 904, that is where my data 1 is present. Then I have to load a number from where? From 908, that is where my data 2 is present. Yes, so that is where my data 2 is going to be present. So first my data 1 is going to present at location 904, data 2 will be present at 908, data 3 will be present at 912, then 916 and so on. Right? You can write and check how it goes on till 940. 10 numbers should be there. So what happens in my code, though I say the same 3 lines, so though I'm saying it's going to be same 3 lines, this is the divide. First 3 lines, it is going to add the first data, okay, 49 with the first data. These 3 lines, it is going to add 49 with the second data. So what happens? From 904, take the first data, load it in register 2. From 900, take 49, add with register 2. Whatever is the sum present in register 2, put it back in 904. Same thing. Load the second data from 908, okay, to the register 2. Add the contents of 900, which is 49, with register 2. Store it. Store the sum back in 908. So what will be the next third line? It will be load the contents from 912. Yes, add 49, which is from 900, and then store it back in 912. Okay, if you see here, just we will take only these two way compare. We will compare only these two, right? We have these 3 lines here, these 3 lines. What do you observe here? What I observe here is only in load and in store there is a change. What is the change? Here it is 904, here it is 908. Here also in store also it is 904, here 908. But this line add instruction doesn't change at all, because your 49 always is going to be there in 900 only. So there is no change in that line. Okay, so only changes just an observation. Just changes there only in load and store. There is no change in add instruction, right? So what I will do, I will copy, just instead of copying I'm just putting dot 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 dot. You understand? So this is going to be 49 at location 900. So you will know how do you calculate your absolute address, right? So we are also writing the absolute address. Okay, I'm saying dot dot so that 2 times I have done it, 2 sets of coding done. Similarly, I have to do 8 more sets of coding has to be done. You understand? This is the first we saw what is the problem. We saw how can we code it. Now we have actually coded it. Okay, this program is now complete because we have done it for all the 10 values, right? So we have done it for all the 10 data. We are adding 49. So that program is now complete. The only problem with this program is that it is a long way, okay, but it will work. There is no looping involved, right? So we have to think of a looping way to loop it, okay, and see if I can do anything else to make it more efficient. Okay, yes, that we will see in the next class.